Hello dear children, welcome back to online classes from Vagdevi Vikas PU Science College. We are discussing a chapter called thermal properties of matter. No? So in that, let us talk about Newton's law of cooling. Newton's law of cooling. Please put this heading, Newton's law of cooling. Very important topic. Derivation can be asked for 5 marks and there will be so many numericals related to this. Okay. Now, Newton's law of cooling, what it says? It says, rate of cooling of a body, rate of cooling of a body, rate of cooling of a body is directly proportional to the difference of temperature of a body or difference between temperature of body and temperature of surrounding. Did you understand this statement? Try to read it, try to write it first. What it says, rate of cooling of a body is directly proportional to the difference between temperature of body and temperature of surrounding. For example, let me take a body here. One body is there. Its temperature is TB. What is this? TB. For example, TB means what? Temperature of body. TB means temperature of body. And I have surrounding, and temperature of surrounding is TS. Let me write it as TS. So TS is going to be temperature of surrounding. Okay, fine. Are you getting my point? What I am trying to say? Temperature of the body and temperature of the surrounding. This is known to you. They are saying, what they are trying to say is, the rate of cooling. What is the meaning of rate of cooling? Rate of cooling means initially temperature of a body was Ti. Ti means what? Initial temperature of body. When I say Ti, the meaning of this is initial temperature of body. And within time T, when you leave this body for time T, its temperature become Tf. What is the meaning of Tf? Tf is going to be final temperature of body. Are you understanding what I am trying to say? Ti is initial temperature of body and within a time T, temperature has become Tf, that is final temperature of body. Okay, fine. Now, temperature of the surrounding is going to be Ts as usual. Ts is going to be temperature of surrounding. Surrounding is a very big thing. This whole universe, it is a big thing. By adding some heat, I cannot increase the temperature. By taking some heat, I cannot decrease the temperature. The temperature of the surrounding cannot be changed. It cannot be increased or it cannot be decreased. It is a big thing. Are you understanding? ಸಮುದ್ರದ ಒಳಗಡೆ ಒಂದು ಗ್ಲಾಸ್ ನೀರು ತಗೊಂಡ್ರೆ ಅದೇನಾದ್ರೂ ಸಮುದ್ರ ಕಡಿಮೆ ಆಗುತ್ತಾ ಅಥವಾ ಒಂದು ಗ್ಲಾಸ್ ನೀರು ಹಾಕಿದ್ರೆ ಸಮುದ್ರ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತಾ? ಇಲ್ಲ. ಸರೌಂಡಿಂಗ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಏನಾದ್ರೂ ಹೀಟ್ ಹಾಕಿದ್ರೆ ಸರೌಂಡಿಂಗ್ ಹೀಟ್ ಆಗುತ್ತಾ? ಸರೌಂಡಿಂಗ್ ಇಂದ ಸ್ವಲ್ಪ ಹೀಟ್ ತಗೊಂಡ್ರೆ ಅದೇನಾದ್ರೂ ಟೆಂಪರೇಚರ್ ಕಡಿಮೆ ಆಗುತ್ತಾ? ನೋ. ಸರೌಂಡಿಂಗ್ ಇಸ್ ಅ ವೆರಿ ಬಿಗ್ ಥಿಂಗ್. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಇದ್ರದ್ದು ಟಿಎಸ್ ಅಂದ್ರೂ ಇದ್ದೇ ಇದೆ. ಓಕೆ, ಇಲ್ಲಿ ಏನಾಗಿದೆ? ಬಾಡಿ ಇಸ್ ಕೂಲಿಂಗ್. ಬಾಡಿ ಏನಾಗ್ತದೆ? ಇಲ್ಲಿ ಕೂಲ್ ಆಗ್ತಾ ಇದೆ. ಮೊದಲು ಟೆಂಪರೇಚರ್ ಟಿ ಐ ಇತ್ತು, ಈಗ ಏನಾಗಿದೆ? ಟಿ ಎಫ್ ಆಗಿದೆ. ನಾವು ಏನ್ ಬರ್ದಿದ್ವಿ ಇಲ್ಲಿ ಬರ್ದಿದ್ವಲ್ಲ, ಏನಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ವಿ? ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ ಆಫ್ ಎ ಬಾಡಿ. Rate of cooling of a body is directly proportional to difference between temperature of body and temperature of surrounding ಅಂತ ಬರ್ದಿದ್ವಲ್ಲ, ನೆನಪಿದೆ? ಅದೇ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಏನ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದೆ ಅದನ್ನೇ ರೀತಿಯಾಗಿ ಬರ್ದಿದ್ದೀನಿ. Rate of cooling of a body is directly proportional to difference between temperature of the body and temperature of the surrounding. ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು? ಮೊದಲು ಎಷ್ಟಿತ್ತು ಟೆಂಪರೇಚರ್? ಜಾಸ್ತಿ ಟಿ ಐ ಇತ್ತು, ಇದು ಜಾಸ್ತಿ ಟೆಂಪರೇಚರ್ ಇತ್ತು, ಆಮೇಲೆ ಏನಾಗಿದೆ? ಇದು ಕಡಿಮೆ ಆಗಿದೆ. ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ ಮೈನಸ್ ಫೈನಲ್ ಟೆಂಪರೇಚರ್. ಏನ್ ಹೇಳಿ? ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ ಮೈನಸ್ ಫೈನಲ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್ ಟೇಕನ್. ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್, ರೇಟ್ ಆಫ್ ಚೇಂಜ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಅಂತಿದ್ರಲ್ಲ, a is equal to ಏನು ಬರೀತಾ ಇದ್ರಿ? v minus u divided by t. ಹೆಂಗ್ ಓದ್ತಾ ಇದ್ರಿ? acceleration is the rate of change of velocity. Final velocity minus initial velocity divided by time taken. Here also rate of cooling means initial temperature minus final temperature. ಯಾಕೆ? ಯಾಕಂದ್ರೆ initial temperature ಹೆಚ್ಚಿಗೆ ಇದೆ, final temperature ಕಡಿಮೆ ಇದೆ. ಅದಕ್ಕೆ ti minus tf divided by t ಅಂತ ಬರ್ತಾ ಇದೆ. So it is directly proportional to difference between temperature of the body and temperature of the surrounding. ಇಲ್ಲಿ ಫಾರ್ಮುಲಾ ಬಂದಿದ್ದು Ti minus Tf divided by T is directly proportional to Tb minus Ts ಅಂತ. ನಿಮಗೆ ಒಂದು ಡೌಟ್ ಬರಬಹುದು, ಈ Tb ಇದೆಯಲ್ಲ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ, ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ಒಂದ್ಸರಿ Ti ಇದೆ ಒಂದ್ಸರಿ Tf ಇದೆ, ಯಾವುದು ತಗೊಳ್ಳೋದು ಸರ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ ಅಂತ ಹೇಳಿ ಇದನ್ನ ಬಿಟ್ಬಿಡಿ. ಇದು ಕಾನ್ಸೆಪ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಕ್ಕೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೆ ಅದನ್ನ. ಬಟ್ ಈಗ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ ಒಂದ್ಸರಿ Ti ಇದೆ ಒಂದ್ಸರಿ Tf ಇದೆ, ಇಲ್ಲಿ ನೋಡಿದ್ರೆ Tb ಅಂತೀರಾ, ಯಾವುದು ತಗೋಬೇಕಂತ ಕೇಳಿದ್ರೆ ಏನ್ ಬರೀಬೇಕು ಗೊತ್ತಾ ನೀವು, ಅಲ್ಲಿ ಆಸ್ ಯೂಶುವಲ್ Ti minus Tf divided by T ಅಂತ ಇದ್ದೇ ಇರೋದು. ಇಟ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು Tb ಬದಲಿಗೆ ಏನ್ ಬರೀಬೇಕು ಗೊತ್ತಾ, ಇಲ್ಲಿ Ti plus Tf divided by 2 ಅಂತ ಎವರೇಜ್ ತಗೋಬೇಕು. ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ Ti ನು ತಗೊಳಂಗಿಲ್ಲ Tf ನು ತಗೊಳಂಗಿಲ್ಲ, Ti plus Tf ಎರಡೂ ಸೇರಿಸಬೇಕು, ಡಿವೈಡೆಡ್ ಬೈ 2 ಮಾಡಬೇಕು, ಮೈನಸ್ Ts ಆಗುತ್ತೆ. Ti minus Tf divided by T, rate of cooling, this is initial temperature minus final temperature divided by time taken, is directly proportional to this is temperature of the body. Instead of Tb I am writing Ti plus Tf divided by 2 minus Ts. Okay, so it becomes like Ti minus Tf divided by T is equal to K. I am using some constant K here, so K bracket, or you can K bracket Ti plus Tf divided by 2 minus Ts. Very important formula. By using this formula only we are going to solve lot of numericals. Okay, here what they are trying to say, rate of cooling of a body. What is the meaning of rate of cooling of body? Initial temperature minus final temperature. ಯಾಕಂದ್ರೆ ಹೆಚ್ಚಿಗೆ ಇದೆ ಕಡಿಮೆ ಇದೆ ಇಲ್ಲಿ, so ಅದಕ್ಕೋಸ್ಕರ divided by time, directly proportional to temperature of body minus temperature of surrounding as per the statement. But Tb, which Tb, Ti or Tf? So both I have taken Ti plus Tf divided by 2 minus Ts. Then I have put this on constant K. This K depends on so many things. Whatever constant K is there, this is called as Newton's constant. But this depends on so many factors. So many factors. ಯಾವ್ದಾದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ? It depends on specific heat capacity. It depends on nature of material and so many other things. Okay, so let us not talk much about this value of K. Okay, fine. Discuss ಮಾಡಿದೇನೋ, I have got one body here. Its initial temperature was Ti. Within a time T, its temperature has become Tf. Okay, and Ts is the surrounding temperature. These things are known to you. Rate of cooling, when I write it rate of cooling, what does it mean? dt divided by dt by dt, right? Rate of change of temperature means what? Temperature is reducing, no? Here temperature is more, here temperature is less, so temperature is reducing. So dt by dt, rate of change of temperature, it is directly proportional to temperature of the body means a Ti plus a Tf divided by 2, then minus Ts. What is the meaning of this dt by dt? Initial temperature minus final temperature divided by time taken. Initial temperature minus final temperature divided by time taken, so that is equal to K bracket Ti plus Tf divided by 2 minus Ts. It is known to you now, very simple equation. By using this equation only we are going to solve all the numericals. Let us take one question here. Okay, temperature of a body changes from 50 degrees Celsius to 40 degrees Celsius in 5 minutes. Temperature of a body changes from 50 degrees Celsius to 40 degrees Celsius in 5 minutes. Find the time taken to change from 40 degrees Celsius to 30 degrees Celsius if surrounding temperature is, let me take it as 20 degrees Celsius. Please write down this question, very important question, very straightforward and easy question. Okay, so what is the first question? Temperature of a body changes from 50 degrees Celsius to 40 degrees Celsius in 5 minutes. So initial case, what is that? Initial temperature minus final temperature divided by time taken. This is known to you. Let us write it for first case. So that is equal to, what is the formula? K bracket Ti plus Tf divided by 2 minus Ts. That is known to you. Okay, in the first case, what is the initial temperature? 50 minus what is the final temperature? 40 divided by what is the time taken? 5 minutes. Let us keep it in minutes only. The final answer what we get will also be in minutes only. Okay, fine. So that is equal to K bracket. Ti is going to be 50 and Tf is going to be 40 divided by 2 minus the surrounding temperature don't change. So that's why 20. Okay, so 50 minus 40 is going to be 10. 10 over 5 is equal to K bracket. 50 plus 40, 90. 90 by 2, 45. So 45 minus 20. Is it alright? Okay, so let me carry forward this. 5 ones are, 5 twos are. So 2 remains here, 2 is equal to K bracket. So 45 minus 20 will be 25. So value of K will be 2 over 25. I got value of K now. Okay, now second case. What is the second case? For second case also nothing will change as usual. Ti minus Tf divided by T is equal to K bracket. Ti plus Tf divided by 2 minus Ts. The normal things will carry forward. Okay, find the time taken. So I have to calculate this time taken to change from 40 to 30. Initial temperature was 40, now it has become 30. So that is like 40 minus 30 divided by time. This is what I am supposed to calculate here. Okay, ಇದನ್ನೇ ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿದೆ. So ಅದಕ್ಕೋಸ್ಕರ ಏನಂತ ಬರೀತೀನಿ ನಾನು t ಅಂತ ಬರೀತೀನಿ. That is equal to k value. What is that? 2 divided by 25. Already I calculated. In bracket. So Ti is going to be 40, Tf is going to be 30 divided by 2 minus Ts is going to be 20. Surrounding temperature is 20. Okay, fine. So 40 minus 30, 10. 10 divided by T, that is equal to 2 divided by 25. Bracket 40 plus 30, 70. 70 divided by 2, 35. 35 minus 20. So it becomes like 10 over T is equal to 2 over 25. Bracket 35 minus 20 is going to be 50. Okay, you can cancel this or you can just carry forward this calculation. You send this T this side, all other things that side. So what will be the answer? Tell me. So T is equal to, you can do this, no? T is equal to, so 10 as usual it remains and it becomes 25 divided by 2 and that thing also comes down and it becomes 1 by 15. Alright, T I have sent that side. 10 is remaining here. As usual 10 is there. Into reverse 25 by 2, then into 15 it becomes divided by 15. So how to do this? 2 ones are, 2 fives are. Next 5 ones are, 5 threes are. So what I am remaining with? 25 divided by 3. When I say 25 by 3, 25 by 3 is going to be 3 ones are, 3 eights are. Then 1 is a carry, 3 threes are. So 8.33 minutes. 8.33 minutes. Did you understand this? From 50 degree to 40 degree Celsius 5 minutes. From 40 degree to 30 degree Celsius it takes 8.33 minutes. This is very important conclusion what I gave here. Are you understanding what I am trying to say? Okay. Now see here, from 50 to 40 degree Celsius when it is coming, it is taking only 5 minutes. 50 degree to 40 degree Celsius only 5 minutes. But 40 degree to 30 degree Celsius 8.33 minutes. It is taking more time. There also only there is a difference of 10 degrees Celsius. Here also there is a difference of 10 degrees Celsius. 50 to 40 only 10 degrees Celsius difference. 40 to 30 also only 10 degrees Celsius difference. But it is taking more time. Why it is like that? Let us see that. So let's take one important question here. See, look at this MCQ question. For example, 50 degrees Celsius to 40 degrees Celsius. When it is converting, it is taking time T1. Okay, and when it is coming from 40 degrees Celsius to 30 degrees Celsius, it is taking time T2. And 30 degrees Celsius to 20 degrees Celsius, let us take that the time is T3. Now they are asking you to take the correct option A, B, C, D. The first option is going to be T1 is equal to T2 is equal to T3, and second option T1 is less than T2 is less than T3, and third option is T1 is greater than T2 is greater than T3. Then T1 is equal to T2 is less than T3. Some options are given like this. Okay, you have to observe this and you have to prepare the answer for this. You have to take one option here. See here, when the body is hot, it takes very less time to become cold, no? Yes or no? 50 degrees Celsius ಇಂದ 40 degrees Celsius ಬರಬೇಕಾಗಿದ್ರೆ ಕಡಿಮೆ ಟೈಮ್ ತಗೊಳ್ಳುತ್ತದೆ. ಪ್ರೂವ್ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ. ಅದೇ ಕೂಲ್ ಆಗ್ತಾ ಆಗ್ತಾದಂಗೆ 30 ಇದ್ದಾಗ 20 ತಗೋಬೇಕಂದ್ರೆ ಆಗ್ಬೇಕಂದ್ರೆ ಇದು ಜಾಸ್ತಿ ಟೈಮ್ ತಗೊಳ್ತದೆ. T3 ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರಬೇಕು. ಸೊ T3 ಇದೆ ನೋಡಿ. T3 ಎಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದೆ, ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದೆ. ಇದು ಅತಿ ಕಡಿಮೆ ಇರುತ್ತಿದ್ದು, ಅತಿ ಕಡಿಮೆ. ಹೌದಾ, ಗೊತ್ತಾಗ್ತಿದೆಯಾ? ಇದು ಅತಿ ಕಡಿಮೆ, ಈ ರೀತಿಯ ಫುಲ್ ಕಡಿಮೆ ಇದೆ ಇದು. ಆಮೇಲೆ ಇದು ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇದೆ, ಆಮೇಲೆ ಇದು ಇನ್ನೂ ಕಡಿಮೆ ಇದೆ. ಅವ್ರಿಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಓಕೆ, ಇದನ್ನ ನಡೆಸ್ಬಿಡ್ತೀನಿ. ಇದನ್ನ ಇಲ್ಲಿ ಏನೇನು ಆರೋ ಮಾರ್ಕ್ ಬರ್ದಿದ್ದೀನಿ ಅದನ್ನ ನಡೆಸ್ಬಿಟ್ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ನಿಮಗೆ. ಫುಲ್ ಜಾಸ್ತಿ ತಲೆ ಕೆಡಿಸ್ಕೊಬೇಡಿ. ದಿಸ್ ಇಸ್ ವೆರಿ ಲೆಸ್ ಟೈಮ್, ದಿಸ್ ಇಸ್ ಮೋರ್ ಟೈಮ್, ದಿಸ್ ಇಸ್ ಅಗೇನ್ ಮೋರ್ ಟೈಮ್. Okay, how to do this? Let us try to understand. ಈಗ ಏನಿತ್ತು ನಮಗೆ ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ ಅಂತ ಇತ್ತಲ್ಲ, ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ is directly proportional to difference between temperature of the body and temperature of the surrounding ಅಂತ ಇದೇ ರೀತಿಯಾಗಿ ಇತ್ತು, ಒಪ್ಕೊಳ್ಳೋಣ. ಈಗ ನೋಡಿ, ಈಗ ಏನಾದ್ರು 50 + 40 ಇದೆಯಾ, ಇದು ಇರ್ತಾ ಇರಲಿ. ಸರೌಂಡಿಂಗ್ ಟೆಂಪರೇಚರ್ TS ಇದೆಲ್ಲ 10 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಅನ್ಕೊಂಡ್ಬಿಡೋಣ ನಾವು. ಯಾಕಂದ್ರೆ 20 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ 10 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇರಬೇಕು, ಅವಾಗಲೇ ಸರೌಂಡಿಂಗ್ ಇದೇನಾಗುತ್ತೆ ಟೆಂಪರೇಚರ್ ತಗೊಳ್ಳೋಕೆ ಶುರು ಆಗುತ್ತೆ. ಈಗ ಒಂದೇ ಕೇಸ್ ಇದೆಯಲ್ಲ, ಈ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ ಅಂದ್ರೆ ಮತ್ತೆ ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ ಏನ್ ಬರೀತೀವಿ, ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ ಬರೆದ್ಬಿಟ್ಟು ಆಮೇಲೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಬಾಡಿ ಅಂದ್ರೆ TI + TF ಡಿವೈಡೆಡ್ ಬೈ 2 - TS ಅಂದ್ರೆ ಅದಂತೂ ಬಂದೇ ಬರುತ್ತೆ, ಅದರಲ್ಲಂತೂ ಏನು ಇಶ್ಯೂ ಇಲ್ಲ. ಓಕೆ ಫೈನ್, ಆರ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್? ಈಗ ರೇಟ್ ಆಫ್ ಕೂಲಿಂಗ್ ಒಂದನೇ ಕೇಸ್ ನಾನು ಏನಾದ್ರು 50 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇಂದ 40 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ತಗೊಂಡು ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್ ಮಾಡಿದೆ ಅನ್ಕೊಳ್ಳಿ. ಇಟ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ 50 ಇಂದ 40 ಅಂದ್ರೆ 50 + 40 90, 90/2 ಅಂದ್ರೆ 45, 45 - 10 ಆಯ್ತು. ಸೊ ಇಟ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು 35 ಆಯ್ತು. ಕರೆಕ್ಟಾ? ಓಕೆ, ಇದೇನಾಯ್ತು ಫಸ್ಟ್ ಕೇಸ್ ಆಯ್ತು. ಅದೇ ರೀತಿಯಾಗಿ ಸೆಕೆಂಡ್ ಕೇಸ್ ನೋಡಿ, ಸೆಕೆಂಡ್ ಕೇಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತದು 40 ಇದ್ದದ್ದು 30 ಆಗಿದೆ, ಇಲ್ಲಿ ಟೈಮ್ T1 ತಗೊಳ್ಳಿತ್ತು, ಇಲ್ಲಿ ಟೈಮ್ T2 ತಗೊಂಡಿದೆ. ಇಟ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು, ಈಗ ಎರಡು ಕೂಡಿಸಿ TI + TF 40 + 30 ಅಂದ್ರೆ 70, 70/2 ಅಂದ್ರೆ 35, 35 - 10 ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು 25 ಆಯ್ತು. ಕರೆಕ್ಟಾ? ಅದೇ ಥರ್ಡ್ ಕೇಸ್ ನೋಡಿ, ಥರ್ಡ್ ಕೇಸ್ ಏನಾಗಿದೆ 30 ಇಂದ 20 ಬಂದಿದೆ, 30 ಇಂದ 20 ಅಂದ್ರೆ 30 - 20 ಡಿವೈಡೆಡ್ ಬೈ T3, ಇಟ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ನೆಕ್ಸ್ಟ್ TI + TF ಇದೆಲ್ಲ 30 + 20 ಅಂದ್ರೆ 50, 50 ಡಿವೈಡೆಡ್ ಬೈ 2 ಅಂದ್ರೆ 25, 20 - 10 ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ 15 ಆಯ್ತು. ಇದು ಜಾಸ್ತಿ ಇದೆ, ಇದು ಜಾಸ್ತಿ ಇರಬೇಕಾದ್ರೆ ಇದೇನಿರಬೇಕು, ಟೈಮ್ ಕಡಿಮೆ ಇರಬೇಕು. ಇದು ನೋಡಿ, ಈ ವ್ಯಾಲ್ಯೂ ಏನಿದೆಲ್ಲ ಇದು ಜಾಸ್ತಿ ಇದೆ ಎಲ್ಲರಿಗಿಂತ, ಇದು ಜಾಸ್ತಿ ಇದೇನಿರಬೇಕು, ಕಡಿಮೆ ಇರಬೇಕು. ಕರೆಕ್ಟಾ? ಆಮೇಲೆ ಇದೇನಾಗಿದೆ, ಇದಕ್ಕಿಂತ ಕಡಿಮೆ 35 ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅಂದ್ಮೇಲೆ ಅವಾಗ ಇದೇನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಲಿಂಕ್ ಮಾಡ್ತಿದ್ದೀರಾ, ಎಲ್ಲ ಗೊತ್ತಾಗ್ತಿದೆ ಏನ್ ಹೇಳ್ತಿದೆ ಅಂತ ಹೇಳಿ. ಈ ವ್ಯಾಲ್ಯೂ ಏನಾದ್ರು ಜಾಸ್ತಿ ಆಗ್ಬೇಕಂದ್ರೆ ಇದು ಫುಲ್ ಎಲ್ಲರಿಗಿಂತ ಜಾಸ್ತಿ ಇದೆ, ಫುಲ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ಮೇಲೆ ಇದೇನಾಗಬೇಕು, ಎಲ್ಲರಿಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕು. ಅಂದ್ರೆ T1 should be least, ಇದೇನಿರಬೇಕು, ಇದು ಲೀಸ್ಟ್ ಇರಬೇಕು. ಆಮೇಲೆ ಇದೇನಿರಬೇಕು, ಇಟ್ ಶುಡ್ ಬಿ ಮ್ಯಾಕ್ಸಿಮಮ್, ಇದು ಮ್ಯಾಕ್ಸ್ ಇರಬೇಕು, ಅದು ಲೀಸ್ಟ್ ಇರಬೇಕು. ಅಂದ್ರೆ T1 ಎಲ್ಲಕ್ಕಿಂತ ಕಡಿಮೆ ಅಂದ್ರೆ ಇಲ್ಲ ಆಪ್ಷನ್ ಇದೆ. ಸೊ T1 is very very less and T3 is very very greater, ಅದು ಕೂಡ ಬಂದಿದೆ. Are you understanding my point? What I am trying to say? One body 90 degree Celsius ಇಂದ 80 degree Celsius ಆಗೋಕೆ ಟೈಮ್ T1 ತಗೊಳ್ತಾ ಇದೆ. ಅದೇ ರೀತಿಯಾಗಿ 80 degree Celsius ಇಂದ 70 degree Celsius ಗೆ ಟೈಮ್ T2 ತಗೊಳ್ತಾ ಇದೆ. ಅಂದ್ರೆ ಈ T1 ಇದೆಲ್ಲ ಇದು ಯಾವಾಗಲೂ ಕಡಿಮೆ ಇರುತ್ತೆ T2 ಗಿಂತ. ಯಾಕಂದ್ರೆ ತುಂಬಾ ಹಾಟ್ ಇರುವಾಗ ಕೋಲ್ಡ್ ಬೇಗ ಬೇಗ ಆಗ್ಬಿಡ್ತದೆ. 90 ಇಂದ 80 ಗೆ ಬರಬೇಕಂದ್ರೆ ಕಡಿಮೆ ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಅದೇ 80 ಇಂದ 70 ಗೆ ಬರಬೇಕಂದ್ರೆ ಟೈಮ್ ಏನು ತಗೊಳುತ್ತೆ, ಹೆಚ್ಚಿಗೆ ತಗೊಳುತ್ತೆ. Are you understanding my point? This is very important to understand all these questions. So let us take one more question. You understood basics of Newton's law of cooling. Let us take one more question. Very important. It takes 5 minutes. It takes 5 minutes to change temperature from 50 degrees Celsius to 40 degrees Celsius. Okay? And also it takes 8 minutes. It takes 8 minutes to change temperature from 40 degrees Celsius to 30 degrees Celsius. Okay? Find temperature of surrounding. Find temperature of surrounding. Very important question. Please make a note of this thing and let's get started. Okay. Now they are asking you temperature of surrounding. Temperature of the surrounding means TS is equal to question mark. Let us handle the first case. Let us take the first case now. It takes 5 minutes to change temperature from 50 degrees Celsius to 40 degrees Celsius. You understand this now? What is the formula? So you know the formula already. So 50 degrees Celsius to 40 degrees Celsius it is becoming in how many minutes? In the time T is equal to 5 minutes. This is going to be Ti, this is going to be Tf, Ts is something I don't know. That's what I am supposed to calculate. How to write the formula? Rate of cooling, that is Ti minus Tf divided by 2 is equal to K bracket Ti plus Tf, temperature of the body, average I have to take, minus temperature of the surrounding, Ts. Alright? Okay. So initial temperature is 50, final temperature is 40. Divided by, this is not a 2 no, this is T, sorry I am really sorry, 50 minus 40 divided by time is going to be 5 minutes, so that is equal to K bracket, Ti plus Tf is going to be 50 plus 40 divided by 2 minus Ts, so it becomes like 50 minus 40, 10 divided by 5, 10 by 5 is equal to K bracket 50 plus 40 90, 90 by 2 is 45, 45 minus Ts. Alright, so 5 ones are 5 twos are, so it becomes like 2 is equal to K bracket 45 minus Ts. Let me keep it as equation number 1. Because this is what I know. By the help of Newton's law of cooling, I am supposed to find temperature of the surrounding. That's why I am doing it. So let us take the second case. In second case, the temperature also it takes 8 minutes to change temperature from 40 degree to 30 degrees Celsius. So initially 40 degrees Celsius was there, and to become 30 degrees Celsius, it's taking how many minutes? 8 minutes. And this is going to be Ti, and this is going to be Tf. That is known to you. Very simple. Okay. Now let us put the formula. Rate of cooling, that is initial temperature minus final temperature divided by time taken is equal to K bracket Ti plus Tf divided by 2 minus Ts. Please make a habit of writing this formula, because all the numericals related to Newton's law of cooling will be solved by using this formula only. Whatever derivation formulae are there, they are used for your board exams only. They are not used in competition. Okay, that is okay. So Ti minus Tf is going to be 40 minus 30 divided by time taken is going to be 8 minutes is equal to K bracket. So it is going to be 40 plus 30 divided by 2 minus Ts. Okay, so 40 minus 30, 10. 10 divided by 8 is equal to K bracket 40 plus 30 is 70, 70 by 2 35, 35 minus Ts. So let me keep it as equation number 2. Okay, I got two equations 1 and 2. Now I have to divide 1 divided by 2, because I have to cancel K. No, I don't know the value of K. I have to cancel them. I have to cancel the value of K, so that here how many unknowns are there? K is unknown, Ts is unknown. Here also K is unknown, Ts is unknown. If I divide this by that, K will get cancelled, no? So that's how I will do 1 divided by 2. Equation 1 divided by equation 2. Equation 1 is known to you, no? What is there on LHS? 2 is there. So let me write 2. 2 divided by, what is there on LHS of 2? 10 by 8. Let me write it as 10 by 8 only. So 10 divided by 8 is equal to, what is on RHS of 1? K bracket 45 minus Ts divided by, what is there on RHS of 2? K bracket 35 minus Ts. That is also there. So I am going to write it as 35 minus Ts. K and K, they will get cancelled. So it becomes like 2 into 8 divided by 10. 2 into 8 by 10. So that is equal to 45 minus Ts divided by 35 minus Ts. Okay. So let me cancel this. 2 ones are, 2 5s are. So let me keep as usual. So 8 bracket. So let me send this 35 minus Ts this side. So 8 bracket 35 minus Ts. And as usual 5, let me send that side. 5 bracket 45 minus Ts. Basic calculations. So 8 into 35. 8 5s are 40. 4 is the carry. 8 3s are 24. 24 then plus 4, 280. So as usual. And 8 Ts minus 8 Ts is equal to 5 into 45. So 5 5s are 25. 2 is the carry. 5 4s are 22, 25. Minus 5 Ts. Alright? Okay. So let me send that minus 8 Ts that side. So it becomes like 280 minus 225 is equal to 8 Ts minus 5 Ts. You can handle with all these basic calculations now. You can do it easily. So 280 minus 225 will be 55 now. 55. Yes or no? 225, then 5 means 230, another 50, so 55. So that is equal to 8 Ts minus 5 Ts is going to be 3 Ts. Okay? So Ts is going to be 55 divided by 3. So 55 by 3 means 3 ones are, 3 ones are. Then 2 is the carry, 3 8s are 24. Then 1 is the carry, 3 3s are. So 18.3 degrees Celsius. Whatever temperature of the surrounding, it is 18.3 degrees Celsius. Very important problem, very easy problem. You should be able to solve it. See here, whenever you get one is K, another is Ts, both are unknown. No? Here also K and Ts. Whenever you come up with such problems in physics, just divide them. Nothing will happen. They will get cancelled and the Ts will interchange, and you can find the value of Ts also. Take one more question here. Graphs between temperature drop with respect to time are given below. Tick the correct option. Okay, 4 options are given to you. Graph A, it is like this. On y-axis I have temperature T, on x-axis I have temperature, not temperature, time T. This is time T, right? And this is going to be temperature. And this is the first graph, and second graph is going to be like this. This is small t and this is capital T. It is going to be like this. And third graph, C is going to be small t, capital T. Let me take this graph like this, and D is like this. Capital T and small t. It has become like this. Okay, take the correct option. Think about it. Think about it, which is going to be correct. Okay, fine. Now they are saying in the first graph, we know, right? So rate of cooling dt by dt is directly proportional to temperature of body minus temperature of surrounding. Yes or no? So they are saying linearly it is changing. Linearly it is changing. As per this graph, so if 50 degrees Celsius to 40 degrees Celsius, 50 to 40, if it is taking time T1, then 40 degrees Celsius to 30 degrees Celsius time T2. They are saying T1 is equal to T2. No, this is not correct. Yes or no? This is a wrong statement. No? Actually T1 should be less than T2. But according to this graph, it is same everywhere time. For example, time 1 second, here also 1 second, here also 1 second, like that they are saying. So that's why this option becomes wrong. Yes or no? Are you getting my point? This option becomes completely wrong. And here what they are trying to say, in B option, immediately temperature has gone down. But afterwards it has remained constant. They are saying this is also wrong. This doesn't happen. Yes or no? Actually what is happening? 50 to 40 and 40 to 30 and 30 to 20. Here if it is how many seconds? If it is 10 seconds, here it is going to be 9 seconds, here it is going to be 8 seconds. Just an example. Here it takes more, I'm really sorry. Here it is going to be 8 seconds, 9 seconds and 10 seconds. Here it is going to take less time. Why less time? Because more temperature is there. So less time it is going to take. Only 8 seconds. Here more time because temperature is less. More time. Again more time. Okay. But according to this graph it is also wrong. And here also it becomes wrong because it has become constant here. And look at this graph. They are saying initially it will happen like this and constant. This is also wrong. But look at this. Gradually it is changing like that. You can draw this graph like this also. No issue. Gradually it is changing. So that's why it becomes a correct option. Because initially it took very less time. Immediately it came. After that it is taking more time, little more time. After that again more time. Now it is taking more time. Are you understanding what I am trying to say? Here if it is taking only 8 seconds, here it is taking 9 seconds, here it is taking 10 seconds. More and more time it is going on. Can you observe this? Here the gap is very less, time gap is very less, only 8 seconds. But here more, 9 seconds. But here, see here, this is 10 seconds. Only this graph, whatever I have written, it is 8 seconds and this one is 9 seconds and this much gap it is going to be 10 seconds. Are you understanding? So here it is less time. When I come into the following things, it takes more and more time. 8 minutes, 9 minutes, 10 minutes together. It keeps on continuing like that. So what I have discussed till now, what is that? Ti minus Tf divided by time taken. Rate of cooling. Initial temperature minus final temperature divided by time taken. That is equal to K bracket Ti plus Tf divided by 2 minus Ts. This is known to you, this formula is confirmed to you. But this value of K, whatever it is, it depends on material, I told you. Depends on material. Okay? Now, for example, I have material 1. Material 1 I have. Okay? So here temperature is changing from 50 degrees Celsius to 40 degrees Celsius in 5 minutes. In 5 minutes. Okay, I have one more material, material 2. Material 2. Here temperature 50 degrees Celsius to 40 degrees Celsius, it is changing in 10 minutes. In 10 minutes. See, here also 50 to 40, here also 50 to 40. But here it is taking 5 minutes, here 10 minutes. Why? Because of material. If this material is 1, means its cooling constant will be K1. Whatever K is there, this is called as cooling constant. ಏನಂತ ಕರೀತಾರೆ ಇದಕ್ಕೆ ಕೂಲಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಕರೀತಾರೆ K1. ಆಮೇಲೆ ಈ ಕಡೆ ಮೆಟೀರಿಯಲ್ ಇದೆ K2 ಇದೆ, ಇದರದ್ದು ಕೂಲಿಂಗ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಅದಕ್ಕೋಸ್ಕರ ಇಲ್ಲಿ 50 ಇಂದ 40 ಆಗ್ತಾ ಇದೆ. 5 ಮಿನಿಟ್ಸ್ ಆಗ್ತದೆ, ಬಟ್ ಇದು 50 ಇಂದ 40 ಗೆ 10 ಮಿನಿಟ್ಸ್. ಇದು ಬೇಗ ಮಾಡ್ತಾ ಇದೆ. 50 ಇಂದ 40 ಗೆ 5 ನಿಮಿಷ ಒಳಗಡೆ ಆಗ್ಬಿಡ್ತಾ ಇದೆ. ಅಂದ್ರೆ ಮೆಟೀರಿಯಲ್ ಏನ್ ಮಾಡ್ತಾ ಇದೆ, ಇಟ್ ಇಸ್ ಲೀವಿಂಗ್ ಹೀಟ್ ಈಸಿಲಿ. 50 ರಿಂದ 40 ಆಗಕ್ಕೆ ಬರೀ 5 ನಿಮಿಷ ಅಂದ್ರೆ ಈಸಿಯಾಗಿ ಬಿಟ್ಬಿಡ್ತಾ ಇದೆ ತನ್ನ ಒಳಗಡೆ ಇರುವಂತ ಹೀಟ್ ನ. ಆಮೇಲೆ ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ 50 ಡಿಗ್ರಿ ಇಂದ 40 ಡಿಗ್ರಿ ಬರ್ಬೇಕಾದ್ರೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತಾ ಇದೆ? 10 ಮಿನಿಟ್ಸ್. ಅಂದ್ರೆ ಅದು ಹೀಟ್ ಬಿಡ್ತಾ ಇಲ್ಲ, ಈಸಿಯಾಗಿ ನನಗೆ ಬೇಕು ಅಂತ ಹಿಡಿದು ಇಟ್ಕೊಂಡಿದೆ. ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಯಾವ ಮೆಟೀರಿಯಲ್ ನಾವು ಯೂಸ್ ಮಾಡಬೇಕು ಹೇಳಿ? ಹೀಟ್ ಸ್ಟೋರ್ ಮಾಡೋದಕ್ಕೆ ಇದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕಾ, ಇದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕಾ? ಆಫ್ ಕೋರ್ಸ್ ಇದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕು. ಯಾಕಂದ್ರೆ ನೀವು ನೀರು ಕಾಸಿರ್ತೀರಲ್ಲ, ಬೇಗ ಆರ್ ಹೋದ್ರೆ ನಿಮ್ಗೆ ಲೈಕ್ ಆಗುತ್ತಾ? ಇಲ್ಲ, ಲೇಟ್ ಆಗಿ ಆರ್ಬೇಕು. ಆರ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಮೈ ಪಾಯಿಂಟ್? ವಾಟರ್ ಪ್ರಾಪರ್ಟಿ ಅದೇನಿದೆ ಅದು ಇರ್ತಾ ಇರಲಿ, ಬಟ್ ಈ ಮೆಟೀರಿಯಲ್ ನಾನು ಏನ್ ಮಾಡಬೇಕು? ಇಟ್ ಈಸ್ ಯೂಸ್ ಟು ಸ್ಟೋರ್ ಹೀಟ್. ದಿಸ್ ಮೆಟೀರಿಯಲ್ is used to store heat. heat ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡಕ್ಕೆ ಇದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕು, ಬಟ್ ಇದನ್ನ ಯೂಸ್ ಮಾಡಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಬಟ್ ಕ್ವಶನ್ ಅದಲ್ಲ. ಈಗ ಏನ್ ಕೇಳಿದ್ದಾರೆ ಅಂದ್ರೆ K1 ಡಿವೈಡೆಡ್ ಬೈ K2 ಇಸ್ ಈಕ್ವಲ್ ಟು ಕ್ವಶನ್ ಮಾರ್ಕ್ ಅಂತಿದ್ದಾರೆ. ಮುಗಿದೋಯ್ತು ಅಷ್ಟೇ, ಮತ್ತೇನಿಲ್ಲ. ಮಾಡಬಹುದಲ್ಲ. ಒಂದನೇ ಕೇಸ್ ಇದೆ ತಗೊಳ್ಳಿ, ಇದೇನಿದೆ ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ ಇದೆ, ಆಮೇಲೆ ಇದೇನಿದೆ ಫೈನಲ್ ಟೆಂಪರೇಚರ್ ಇದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ಎರಡಕ್ಕೂ ಸೇರ್ಕೊಂಡು ಸರೌಂಡಿಂಗ್ ಟೆಂಪರೇಚರ್ TS is equal to let me take it as 20 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಅನ್ಕೊಂಡ್ಬಿಡೋಣ ಅದರಲ್ಲಿ. ಓಕೆ ಫೈನ್. ಆಮೇಲೆ ಇಲ್ಲೂ ಕೂಡ ಇದು ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ ಇದೆ, ಇದು ಫೈನಲ್ ಟೆಂಪರೇಚರ್ ಇದೆ, ಇದಕ್ಕೊಂದು ಫಾರ್ಮುಲಾ ಬೇರೆ, ಅದಕ್ಕೊಂದು ಫಾರ್ಮುಲಾ ಬೇರೆ, ಎರಡು ಡಿವೈಡ್ ಮಾಡಿಬಿಡಿ. K1 divided by K2 ಬರುತ್ತೆ. ಓಕೆ, ಫಸ್ಟ್ ಕೇಸ್, ಲೆಟ್ us take first case. What will be the first case? Ti minus Tf divided by 2 is equal to K1. Now K1, why? Because material is different. Here also material is different. So K1 bracket Ti plus Tf divided by 2 minus Ts. Okay, so Ti minus Tf, so 50 minus 40, so it becomes like 50 minus 40 divided by 2 is equal to, not divided by 2, sorry, divided by T, no? I'm really sorry, I'm making that mistake again and again. This is time T, not 2. So 5 minutes, so 5 is equal to K1, as usual it will be K1 bracket 50 plus 40 divided by 2 minus Ts is given, no? What is that? 20. Okay, so 50 minus 40 is 10. 10 divided by 5 is equal to K1 bracket 50 plus 40, 90, 90 by 2, 45, 45 minus 20. So 5 ones are 5 twos are. So 2 is equal to K1 bracket 45 minus 20, 25. So let me keep it as equation number 1. Let us look for second case. In second case also formula will remain same. What is that? Ti minus Tf divided by T is equal to K2. This K2 is different because material is different. So in bracket Ti plus Tf divided by 2 minus Ts. Okay. In second case, what is that? Again 50 to 40 is there. 50 to 40. 50 minus 40 divided by, this time is going to be 10 minutes. Initially it was 5 minutes for the first case. For second case it is going to be 10 minutes. So that is equal to K2 bracket. Again 50 plus 40 divided by 2 minus Ts is going to be 20. Okay, as usual. Okay, now what will happen? 50 minus 40, 10. 10 divided by 10 is equal to K2 bracket 50 plus 40, 90, 90 by 2, 45. 45 minus 20. So it becomes like 10, 10 ones are 10 ones are 1 is equal to K2 bracket 25. So let me give it as equation number 2. Let me divide equation 1 divided by equation 2. What is equation 1 RHS 2? What is equation RHS of equation 2? 1. That is equal to LHS of 1 K1 into 25. K1 into 25 divided by, here it is K2 into 25. So 25, 25 they are getting cancelled. I want K1 is to K2 now. So K1 divided by K2 is equal to 2 is to 1. I got it. Over. This is the answer. K1 by K2 they have asked now. So 2 divided by 1. This will be the answer. Okay, options will be given to you. A, B, C, D. How they will be given? 1 is to 2, 2 is to 1, 1 is to 3, 3 is to 1. So 2 is to 1. So this is the correct option. They must have given option like this, but you should be able to solve these kind of problems also. Now observe one thing here. I got K1 divided by K2. What I got? K1 divided by K2 is equal to, I am getting it as 2 is to 1, no? 2 is to 1. That means K1 is more. This value is more. This value is less. If it is more, we should not use for storing heat. If it is less, I should use it for storing heat. Observe here. This value is less. This K2 value, cooling constant it is. If cooling constant is less, I should be using it to store heat. Are you getting my point? I have one material here. For example, I have one material with K is equal to 10. I have one more material with K is equal to 20. Which material should I use for storing heat? Whoever value is less. K value is less, no? This K, what is the meaning of this K? This K is nothing but cooling constant. If cooling constant is less, the body will cool very slowly. So that's why I should use it for storing heat. This material, first material, I should use it for storing heat. Are you understanding what I am trying to say? Okay, got it, no? So its value is 10. Cooling constant is less means I should be using it for storing the heat. If it is more means cooling constant is more, it will quickly cool. So that's why I should not be using that for storing heat. So you understood basics of the Newton's law of cooling. Let me give you some homework question. So question number 1, please take it. 90 degrees Celsius to 70 degrees Celsius, it takes 5 minutes. It takes 5 minutes. Okay. Now please find out from 70 degrees Celsius to, or let me take it as 100 degrees Celsius to 80 degrees Celsius. What will be the time taken? T is equal to question mark and temperature of the surrounding is going to be 50 degrees Celsius. Please do this problem. You understand this problem now? 90 to 70 takes 5 minutes. If surrounding temperature is 50, how much time it takes from 100 degrees Celsius to 80 degrees Celsius? You can do it easily. Let me give you another question. What is that? That is 90 degrees Celsius to 70 degrees Celsius or 90 to 40 degrees Celsius in 10 minutes. In 10 minutes. Okay. Then 40 degrees Celsius to 10 degrees Celsius. 10 degrees Celsius, it takes 5 minutes. It takes 5 minutes, just randomly given. Now they are asking you what is the temperature of the surrounding. They are asking for temperature of the surrounding. For example, I have one material here, material 1 is there. So that's why it takes 50 degrees Celsius to 10 degrees Celsius. It takes 10 minutes. Take 10 minutes. And material 2, I have material 2. Material 1 means K1 and material 2 means what will be the value of constant? K2. So here it takes 40, let me take it as 50 degrees Celsius to 30 degrees Celsius in 2 minutes. Just randomly giving 2 minutes. Okay. Temperature of the surrounding is going to be 5 degrees Celsius. Okay. Now they are asking you K1 divided by K2 is equal to question mark. And they have added one more question here. Which material should be used? Which material should be used to store heat? Store heat. Okay. I have given these 3 problems. First one is there. Second one I have written. Already third one is also known to you. I hope you understand. Material 1 50 to 10 minutes. Material 2 50 to 32 minutes. K1 by K2 is asked. And which material we should use? You should find out the value of K1 and K2 ratio. Then you should be telling them. Whichever K value is less, that takes, yes or no, cooling constant is less, no? It takes more time to cool. So that's how you are supposed to understand those things. When I come into the next class, I will derive this. To derive the Newton's law of cooling, I need some other things related to radiation. But those things are deleted in your syllabus due to this corona and all. So that's why I will take care of all those small details, and in the next class I will be deriving. Till then, keep on studying, keep on watching all these videos. Thank you very much. Have a good day. All the very best for all of you.